Welcome to Lab 8 of CSE 4308. In this lab, we will be taking a look at cascading delete, views, and roles. So let's get started. Cascading delete or onDelete cascade is a clause in our foreign key declaration that basically allows us to automatically delete all the entries that are related to the foreign key in our child table if that entry is deleted from our parent table. So what this basically means is that if we have a parent table and a child table, and if an entry is deleted from our parent table, then all the entries in the child table which are related to that entry in the parent table are automatically deleted. So let's not worry about definitions too much, and let's look at how this works in an actual example. Imagine that we have two tables, phone number and customer, from a telecom company. In our phone number table, phone num is the primary key, and in our customer table, cust ID or customer ID is the primary key. In the phone number table, customer is a foreign key that is referencing cust ID or the primary key of the customer table. Now that we understand our table, let's think of a scenario. Imagine that a customer with the name D and customer ID 4 has decided to not use his SIM anymore. So basically, this entry here is no longer of any use to us. So we do not need this row anymore, so we decided to delete this entry from our customer table. But now what happens is that in our phone number table, we have this particular entry that is related to that past customer with the customer ID number 4, and we do not need this entry either. We have a redundancy in this table because this entry is related to a customer that does not exist anymore, and it is entirely possible that this phone number table has more entries related to this customer that are also of no longer any use to us. So to reduce this redundancy, we need some sort of way so that whenever an entry is deleted in our customer table, then all the entries that are related to that customer in our phone number table are also automatically deleted. So that's where cascading delete helps us. So if we have declared the cascading delete constraint or the cascading delete clause in our foreign key constraint declaration, then whenever an entry is deleted from our customer table, then automatically that all the entries that are related to this entry here are deleted from the phone number table as well. So now let's take a look at how this works by looking at the syntax of cascading delete. All right, so the general syntax for cascading delete is as follows. First, we write our usual statements for creating a table. And in the statement where we declare our foreign key, we simply write onDelete cascade. All right. So that is the general syntax of how we can declare a cascading delete in our foreign key constraint declaration. So let's look at an actual example. First, we connect to our database under the user, under which we want to create the tables. All right. So at first we create our customer table and we declare the required attributes, just like the ones that have been shown in the table earlier. As you can see, we have declared our customer ID as the primary key. All right, then let's move on to our phone number table. And in this table, we have the following attributes, where phone number is the primary key. And next, we have another constraint declaration, which basically declares customer, that is this attribute, as a foreign key that is referencing customer ID of the customer table. And here as well, we have used the onDelete cascade clause, as we have shown in the general syntax. So what happens is that after declaring this specific clause, our cascading delete should work. So whenever we delete an entry from our customer table, then all the entries that are in our phone number table that are related to the customer in this table that has been deleted should also be deleted from the phone number table. So let's see how that happens. So in our SQL console, we create the customer table and we insert the rows that we have shown earlier in this table. Next, we create the phone number table, and we also insert rows that have been shown earlier in this table. Next, let's look at what these tables look like for now. All right, so as you can see, we have not deleted any row yet, so both the tables are intact. Now, let's imagine that we will be deleting this row. That is, we will be deleting the row with customer ID is equal to 4. So let's do that. All right, now that we have deleted this row, let's see what the customer table looks like. Okay, so as you can see, in the customer table, we do not have a fourth entry anymore, where the customer ID was equal to 4. But now the main question is whether this corresponding entry in the phone number table with customer ID is equal to 4 has also been deleted or not. So this is the moment of truth. Let's find out. All right, so as you can see, since we have deleted the entry in the customer table with customer ID is equal to 4, the corresponding entry in the phone number table with customer ID equals to 4 has also been deleted. So we can say that our cascading delete is working as intended. And this is how you can implement cascading delete in your database. Now, the thing about cascading delete is that you need to be careful and you need to practice caution whenever you decide to use cascading delete, because in some cases it might happen that you do not want to delete the child information whenever the parent information is deleted. So for example, imagine that we have two entities, instructor and course, and in the course entity, we have an attribute called instructor, which is basically a foreign key that is referencing the instructor table. Now, if an instructor decides to leave the university, then his information or his entry will be deleted from the instructor table. But if we have declared cascading delete in our course table, what would happen is if we delete the instructor entry from our instructor table, then all the courses that are in the course table that has that particular instructor as its teacher or as its instructor will also be deleted. So we do not want that. We do not want the course informations to be deleted from our course table, do we? So basically, we do not want to declare cascading delete in this case. So what we understand is that cascading delete is a very useful tool. However, we need to understand when to use it and when not to. All right, with that out of the way, let's move on to the next topic. Our next topic is views. Views are basically virtual relations or tables that are defined by queries. So basically, these virtual relations contain the results of those queries. One of the special attributes of views is that they are not pre-computed and stored. Rather, whenever a view is used or a view is called, the query that is used to create that view is executed, and that view is generated dynamically. So views are always updated, whether or not you have updated them in the view itself or not. And it's not even possible to actually update the views. You can update the tables from which the views are generated, but you cannot update the views themselves. These definitions may not be clear the first time you hear it, but after looking at examples, they will become much more clear. But to actually understand the advantages of views, let's first look at the three layers that are present in our data model. So the first layer is the physical layer. And this physical layer basically denotes all the physical storage devices like hard drives or SSDs where our database is stored. Now, we are not really interested in the physical layer. Let's look at the two upper layers now. So next we have the logical layer, and this is basically the layer where programmers like us and other database designers work. So think back for a bit. So far, all the labs that we did, we have been working with databases by creating tables, manipulating tables, by inserting and deleting rows, modifying columns, and so on. Basically, we have been working with the logic of the database. We have been manipulating databases. So essentially, we can say that we have been working in the logical layer. But what about the end users? Where do the end users go? Well, for that, we have the uppermost layer, the abstraction layer. Now, in this abstraction layer, all the users or all the end users are located. So basically what this means is that the end users do not see any logic that goes on behind the scenes of the application that they are using. The end users do not need to know the intricacies or the complications of the database that we have designed, or they do not need to understand the logic that goes on to make those databases work. They only need the final product, that is an application that just works. So we say that end users are part of the abstraction layer where they are given only the results of the application, not the actual working or the actual logic behind that application. Now, views are essentially part of the abstraction layer. There may be multiple views in the abstraction layer, and each of these views basically perform individual tasks, and they perform these tasks so that end users can meet their requirements. Now, these views do not contain the logic behind the working of those applications. All they contain is the result that are calculated by the logic present in the logic layer. Now, let's take a look at how these views work. So we have taken the two tables that we have used previously, and we will be using them to generate our views. Now, imagine that we want to create a view that has the name, gender, occupation, phone number, and the opening date of a customer. So we need 5 attributes that are present in these two tables. All right, so let's see how we can do this. All right, so the general syntax for dropping a view is simply drop view, then the name of the view that you want to drop. Similarly, for creating a view, the general syntax is create or replace view, view name as, and then you type your query. Here, view name is anything that you want to name your view. It can be anything, it does not really matter. You can also simply use create view, view name as, and then type your query. The difference between these two is that if a view already exists with this view name that you are using, then that view will be replaced with the new view. All right. So let's see how this works in an example. So we will be creating a view named customer info and we will need those 5 attributes that we mentioned earlier in this view. So let's create that. So create or replace view customer info, and here customer info is the name of the view as, and then we type our query. So you can see we have written select name, gender, occupation, phone number, and opened from customer, phone number. So as you can see, since we need these 5 attributes and these 5 attributes are spread over these 2 tables, we are using join to basically get these attributes from these 2 tables. But we have to also specify a condition so that we do not get any repeated entries, right? So we specify the information that the phone number dot customer is equal to customer dot customer ID. What this basically means is that the customer ID in both the tables, in both the phone number and customer table, has to be the same, and only those rows where both these attributes are same will be selected for creating our view. So we can also perform queries on this view. So suppose we want to perform a query where we want to see the name and occupation from this view. We can simply do that as well. Now let's see what happens if we type these commands in our SQL console. So as you can see, we have written the command to create our view customer info, and we have used the same syntax that we have shown in the last slide. So after this view has been created, let's see what it looks like. Okay, so as you can see, it contains the 5 attributes that we have mentioned in our initial command, and it also does not have any repeated entries because we have used the condition that the customer ID has to be the same in both those tables, and only those rows will be selected. Now, let's perform other queries on this view. Suppose we want to see the name and occupation from this view, and as you can see, we can perform those custom queries as well. Now, one of the special attributes or one of the special properties of views is that they are automatically updated whenever their parent table is updated or parent tables are updated, right? So suppose we want to change this specific value, the name of the customer A, to something else. So let's do that. All right, so as you can see, we have updated our customer table, and in this table, we have stated that we are changing the name of the customer whose ID was 1 to A. All right, so his initial name was A, but now his name will be X. So let's see if this change is reflected in our view. So remember that we did not do any modification to our view, as it is not even possible to do a modification on views. We have only performed an update on the parent table customer. So let's see if this change is reflected in our view. All right, so as you can see, our name here is X, whereas it was initially A. So we can see that our view is working perfectly, and it is working as intended. Now that we understand views, let's move on to the next topic. All right, so our final topic will be role-based access control. So in a database, whenever we design it, we are not specifically designing it for any one user. In most cases, we will be designing a database for multiple types of users. And these users do not need access to the whole database to meet their requirements. They only need access to certain parts of the database to actually get their job done. So the way we can achieve this is we can create specific roles and grant special permissions to these roles. So when we say special permissions or privileges, we mean that we are granting these roles permission to view or modify certain tables of the database, not all of them. Next, we can do something like we can grant one role to another role. We will see what this means in an example. And finally, whenever our roles are finally created, we give these roles to our users. Each user will have a specific role, and that role will help him get access to a certain part of the database. So we will be using the previous two tables that we have used earlier to demonstrate how this role-based access control work. Now, imagine that we have some requirements set. Our first requirement is that our customers should be able to view their information from the table. So basically, our customers should have access to this customer table, but only in read-only form. They do not need to be able to modify this information here. They only need to be able to view the information that is present here. All right. Our second requirement is that there should be a specific role for operators who can access this customer table and update or modify this information. So basically, an operator will have the ability to modify the information that is present in this customer table. So let's try to create roles based on these requirements. So the general syntax for creating a role is create role, and then the name of the role that you want to use, anything. Similarly, for dropping a role, you can simply write drop role and then the name that you have used to define that role. Next, if you want to grant privileges on a specific table to a role, you can simply write grant privilege name on table to role name. Now, in this whole statement, let's see what each of these parts mean. Privilege name is the name of the permission or the privilege that you want to grant. Table name is the name of the table on which you want to grant those privileges on. Finally, role name is the role to which you want to grant those privileges. We will take a look at an example in detail to understand this whole statement. To grant, after creating this role, to grant it to another role, we can write something like this: grant role name 1 to role name 2. So what this means is that suppose you have created a role and you have granted it specific permissions. Now you have decided that you need to create another role, and it will have a set of more elaborate permissions, but it will also contain the permissions that were given to the first role. So instead of writing all those privileges all over again, you can simply write something like grant role name 1 to role name 2, and automatically all the permissions that were granted to role name 1 will be granted to role name 2 as well. So this is a very handy way of passing on permissions or privileges. Next, let's look at our scenario, and let's look at how this syntaxes can be used in those cases. In that case. Right, so first we will be connecting to the server as the owner of the whole database. Basically, we will be connecting to the database as the user under which we have the customer table and the phone number table. In our case, it was owner and our password was test password, so we have connected to the database. Next, we will be creating our example customer and our example operator. So these two are our users, correct? So we will be creating users using the syntax that we have learned in our first lab. So we have created a user with the name example customer 1, and his password is password, and we have created another user whose name is operator 1, and his password is test123. So after creating these two users, we need to give them the create session permission so that they can log in to the database. If you remember, if we do not grant this specific create session permission to our users, they will not be able to log in to the database. All right. Next, we will create a read-only role and grant it the permission to view the customer table. So this role is for our customers who wish to view their information from the customer table. Note that this is only a read-only role, and they will not be able to modify the information inside the customer table. So let's create it. So first we will create the role, and we have named it role read-only customer. Next, we will grant it the permission to view the entries in our customer table. So we have written something like grant select on customer to role read-only customer. So look at the general syntax for granting privileges on a specific table, and then match it to the one that we have written here. As you can see, for privilege we have used select. So this means that whoever has this role will be able to use select statements on that table. And customer is the table on which we are specifying that privilege on. Finally, we are granting this privilege to our role that we just created, role read-only customer. All right. Next, we will create a role that can actually modify the customer table information. So the thing about this role is that it will be able to perform select statements on our customer table, and at the same time it will be able to perform insert, delete, or update operations in that table. So basically it will have the same permission as the previous role, and it will also have some additional permissions. So since it will have the same permission as the previous role, we can simply write after creating this role, obviously, we can simply write grant role read-only customer to role modify customer. So first we have created the role modify customer, and then we have written this grant role read-only customer to role modify customer. So this is the same as the general syntax of where we have granted the permissions of one role to another role. So in this way, we have granted the select permission to the role modify customer role as well. Next, we will be giving it the other permissions that are required to actually modify the table. So we will grant it the insert permission we will grant it the delete permission, we will grant it the update permission. So we have finally given it all the permissions that it needs to perform modifications on our customer table. Now that we have finished creating and giving privileges to our roles, we can finally grant these roles to our two types of users, our customer and our operator. So we have granted our read-only role to our customer, and we have granted our modification role to our operator. So in this way, by following the general syntaxes, we have created roles, we have granted them privileges, and we have granted these roles to our users. Now let's take a look at how these roles work in our SQL console. All right, so first we have created our example customer using the syntax that we just showed. Next, we have created our operator as well. After creating our customer and operator, we grant them the create session privilege so that they will be able to log in. After that, we have created our read-only role, and we have given it the select privilege so that a person with this role will be able to view all the entries that are present under the customer table. All right. Next, we have created our modification role. So this role will be responsible for doing any sort of modification to our to our customer table. Now, this role will also have the view permission that we gave to the read-only role. So we simply give the read-only role to this role as well. After that, we grant it the privileges to be able to modify our customer table. So we give it the insert, delete, and update permissions as well. Now that we have created our roles, we can finally grant these roles to our users, that is our example customer and our operator. So we granted the read-only role to our customer, and we granted our modification role to our operator. Now, to check whether or not our roles are working, let's connect to the system as the user, as the customer, right? Now, as you can see, there are no tables that are present under this customer, all right? So there are no tables or entities that have been created under this customer user. So we see that whenever we try to show all the tables that are present under this user, we see no rows selected. So remember that we were given the permission to view the customer table that is present under the owner user. So let's see what happens when we write something like this. So as you can see, we have tried to view the entries present in the customer table, but we got an error that says that we do not have this table or view. So what this means is that we are trying to access a table that is not present under the user customer. Instead, what we will do is we will write this: select star from owner.customer. This will specify that we are specifically looking for the customer table that is present under the owner user. All right. So when we execute this query, as you can see, we get our results. So we can see that our view role, our view read-only role is actually working. So now let's try to do something else. Let's try to see if we can do modifications to this table as the customer. So if our role is working properly, we should not be able to do so. Let's see what happens. So we are trying to insert a new entry under this customer table with the customer ID 4. So if our role is working properly, we should not be able to do this. And as you can see, we can't. We get the error, insufficient privileges. So we understand that our role is working perfectly. You can try doing the same thing by logging in as the operator and see if your roles work or not. So that concludes our discussion for this lab. Hopefully you were able to understand the concepts and you will be able to implement them in your future projects or in the next lab task that you will be doing. So take care and stay safe.